Good evening. I just wanted to show off something that I've been working on for the last 5 weeks. I do most of my rendering in OpenGL, but I've decided to try to get DirectX up and running. So what I've done for the last 5 weeks is I've used a lot of my OpenGL functionality, and I've just done everything I could to duplicate it inside DirectX. I don't have any complex shaders running yet, but here on the screen you can see I have a depth texture rendering. I have two versions of an alpha texture, and these are side buffer textures that I'm copying to the screen, decaling on a polygon. These are RGBA, and this is an RGB, and a few others to test some colors. And right now it's in OpenGL mode, and if I switch to DirectX, this one's missing because this is an object type that I have not yet converted, but everything else here is rendering pretty much identical. I'll go back to OpenGL for just a moment and then switch back to DirectX again. You can see for the most part that it's rendering exactly the way it should. You might notice right here in OpenGL it's a little bit more pixelated. It's a little bit smoother in DirectX, probably because I'm sampling the textures differently. So back to OpenGL. Here's a buffer test. I'm going to drag my window around a bit if I can grab it with my mouse. Why isn't this working? There we go. So oh, okay. I'm trying to remember how I did all of this. So this is a screen where I'm just copying, I'm doing rectangle copies from OpenGL buffers to the main buffer. So these were rendered off screen. This is a cube, two cubes next to each other that I've rendered, and then I rendered a red quad to splice it. And I rendered these white quads in front of these in order to demonstrate that I've also copied the depth buffer over. So the white quad is being spliced, but then right here is also another area where I've grabbed this part of the cube and I've copied it into this square. I copied this into an off-screen buffer and then copied that off-screen buffer to here with depth and then rendered this red quad on top of it, just to demonstrate that I can copy a buffer and preserve the depth. And if I switch over to DirectX, I get the exact same identical result. So I was able to duplicate them. But copying buffers in DirectX, you can accomplish that with the copy resource command, but I wanted to copy sub-rectangles too, so I do it basically as a texture render. And I sample the depth buffer as well and set those values, and it pretty much does the same thing as OpenGL, and that serves me just fine. Here's a demonstration of a cube that's just moved and transformed, and then here the scale, and it's scaled and rotated a bit just to give it a weird orientation, and just demonstrates that both OpenGL and DirectX are doing the same thing identically, which is easy in Shader because you can fully control how the MVP matrix is handled in the shader to calculate the vertex positions. So I was able to guarantee to get identical results between the two. This is a clip plane. You can see the front corner of the cube is clipped as well as part of the backside, and I learned a bit about how clip planes are stored. If you just take a clip plane equation and apply the model view matrix to it, that puts it in view space, and you store that, and then when you pass the vertices into the shader, you run your model view matrix on those to put those vertices also into clip space, and that puts both the vertices and the clip planes into the same space, and then you can do your clip plane calculations on them. So if you're pushing and popping matrices, you could be anywhere at any stage while you're performing matrix operations. As long as you apply the current model view matrix to a clip plane the moment you enable it and store that value for presentation to a shader, and then after you present your vertices to the shader for rendering, you also run the model view matrix on those to put those in view space. Then both of them will be in the correct space with each other to do your calculations on. In OpenGL previously, I was only setting up clip planes for shaders in right after I apply the camera view, which allowed me to set up clip planes in the world space, and that's how I was doing all of my calculations. But I might go back and convert that and apply model view matrix to all of my clip planes to put them in a better space. But I'll save that for a later time. This is just an orthographic projection with some demonstration of some fonts up here in the corner, and you can see if I switch to DirectX, they're pretty much identical with each other. OpenGL has this odd little first render problem where they appear as full rectangles and then they change to normal. I haven't really tried to chase that down and fix it. I'm not too concerned about it right now. Here's another test where I'm doing just plain old depth testing, and then here I use depth range to clear out a section, and then I render a darker rectangle or a quad that's actually farther away behind this larger one, because I've set the depth range to a higher value and basically erased this area of depth. I can render something else there with depth testing enabled, and the farther quad gets rendered because the depth here was basically erased by the depth range setting. And this is just stenciling. But both OpenGL and DirectX are rendering identically here as well. Here's blending and color masking. So here I'm rendering, I believe I'm rendering alpha blending, but I'm only rendering red, green, blue, and then all of them at the bottom. Up here I'm doing additive blending. Here I'm doing the typical kind of blending where you would use with smoke, where the object in front, its color takes precedence over what's behind. And in this section right here, I'm demonstrating how the main buffer has an alpha value to it. And so I was able to just prove that both OpenGL and DirectX are just giving me the exact same results. Here I'm flipping the cull face and rendering the back sides, the front sides, and then rendering as wireframe. And this is one case where DirectX is different from OpenGL. With DirectX, you see all the triangles because I'm rendering them as shaders. But in OpenGL, I'm using the fixed pipeline, and I present them as quads, so OpenGL just renders them as quads, and I'm not too worried about making them identical, but at least these two are absolutely identical. Here I was trying to duplicate OpenGL's point sprites and line sprites, and it actually took some work. In DirectX, I had to actually create a point sprite texture and use that for the point rendering. And I don't quite have the line widths and presentation quite correct. I think I know how to fix it. I just have to go back and do so. So if you watch the two purple dots and red dots just above the word red, when I switch to DirectX, you might see them change just a little bit. So that's a point sprite texture that I'm applying to try to just imitate the point sprite ability of OpenGL. And if you look to the lower right of the cube, where the thick blue line stops as it extends and stops just above the word DirectX, you'll see how the very end of it has a slight tilt to it when I switch between the two. And that's because I haven't quite calculated the lateral vector for rendering the line yet. And I'll come back to that at some point, but I wanted to move on. This is just a test of the Q coordinate in texture mapping. The left trapezoid represents the proper use of the Q coordinate to keep it proper, and the right side is where you don't use the Q coordinate at all. And again, just demonstrating that OpenGL and DirectX are doing the exact same thing there. And this is a UI that I developed some time ago. I just wanted to prove that I could render it in DirectX, and I'm using the line routine from a couple of screens ago to render the borders. In OpenGL, they look a bit smoother and nicer because OpenGL allows me to activate line anti-aliasing, with the line smooth ability, but DirectX, I presume it's more pixelated here, but if I wanted to do it in DirectX, I guess I would have to activate some sort of multi-sampling, which I'm really not ready to do yet. So this is fine the way it is, and I'll come back to it at a later time. And I think that's it. Yes, it is. So this is like 5 or 6 weeks of work. I guess one other thing I can show is that both DirectX and OpenGL are now allowing red, green, and glyph. And again, the middle right section I haven't converted over to DirectX yet, so I'm not worried about that. And then they can both do split screen, and they can do barrel distortion. I was really glad to get this working. I realized there was an issue with my constant buffers. I wasn't putting values in the correct place, so the constant buffers weren't being sent across to DirectX properly, so I was getting some really funky results. But I'm really glad that I got this up and running. And this is just a different version of barrel distortion that would apply for an iPhone that's larger. I do have OpenVR rendering, but DirectX is throwing some constant errors. It does display in the headset, but it's the debug output is throwing some constant problems with trying to copy a sub-resource of a buffer from one format to another. I'm not quite sure how to handle that yet, but it's working and it's running. I don't have to fix it, but I'd really like to get rid of those warning messages. I have yet to get OpenXR working. That's going to take a little bit of work, and I'm going to learn a little bit about the sRGB textures in the meantime. So my next big step is to work on a deferred rendering, and since I'm at a point in DirectX where I can start working on the more complex shaders from scratch, I can design from the ground up how to do a deferred renderer where I collect all of the color, normal, and pixel position information into separate buffers, and then just stack lights on it until I can have 50 to 100 lights on the scene, and then build the entire rest of the scene by doing a multiply against the collected colors. So I'm excited to do that. It's going to take it's going to take a good number of weeks to get that up and running, I think, but I'll be glad to see it working, and I'll render a video that shows all of the different stages of the deferred renderer and the kind of data that I'm collecting, and I'll also get some experience working on ambient occlusion. I'm really curious about how to get that working. So that's it for now. I'll continue my work, and when I have a new video to show off, I will do so. Thank you for watching.